All right, here's another example, example number 8 of our different motion problems from 6.7. It says here that John travels 15 kilometers per hour in still water. He motors 140 kilometers downstream in the same time it takes to travel 35 kilometers upstream. What is the speed of the river? We want to figure out how fast the river is moving. Maybe you want to call that R for speed of the river. I don't know. And then let's go through the word problem and kind of highlight the important information. It looks like this 15 kilometers per hour is a speed, right? It looks like this 140 kilometers is a distance. And it looks like this 35 kilometers is also a distance. Now the 140 is the distance going what? Downhill. This is a distance going uphill. And then the speed is the speed in still water. If there's no current, that's how fast his boat or whatever this is goes. Okay, how are we going to make this into a math problem? Well, what else does it say? Does it say that their speeds are the same? Does it say their distances are the same? Does it say that their times are the same? On this one, it says that the times are the same. So can I take that and make an equation from it? The same time it takes to go downhill or downstream is equal to the time that it takes to go upstream. Let's make an equation that says that. So I know that it takes the same time down as it does up, so I can set their times equal. Well, we don't know their times, right? But we do know that time is the same thing as distance over rate. So the distance downhill over the rate downhill is equal to the distance uphill or upstream and the rate upstream. So let's see if we can plug in some information. Do we know the distance that that John went when he went downstream? Yeah, wasn't that the 140? And we know the distance that he went upstream was 35 kilometers, so we can plug that in. Do we know the speed that it took to go upstream or downstream? Now be careful. We only know the speed that it took him in still water. So now we've got to think about going upstream or downstream. If we called the speed of the river R, when I go downstream, aren't I going to go faster? I'm going to go the river's speed plus my speed, so 15 plus R. Now, if I go upstream, aren't I going to be slowed down a little bit by the current of the river? So my speed is going to be lessened by the speed of the river. So that means my speed, 15, is going to be slowed down by the speed of the current of the river. So I'm going to say 15 minus R. Not R minus 15. I'm not going to slow down the river. The river is going to slow me down. So I need to make sure that I put it in that order. The river is going to speed me up when I go downstream, but the river is going to slow me down when I go upstream. So whatever my speed normally is, minus the river's speed. Whatever my speed is normally, plus the river's speed when I go downhill. Hopefully that makes sense. All right, now that I have all the important information into an equation, it looks like this is also a proportion, two fractions set equal to each other. So I should be able to cross multiply and solve. I'm going to do the 140 times the 15 minus R, making sure you distribute. And I'm going to do the 35 times the 15 plus R, making sure that you distribute. After I distribute all of my values, I ended up getting this equation. And now I can move all of my variables to one side, all of my constants to the other side, and I can solve for R. Remember that R is the speed of the river. When I do that, I'm going to add 140R to both sides, and I'm going to subtract the 520. I ended up getting a 1,575 equals 175R. I divided both sides by 175, and I ended up getting R equals 9. Remember that R represented the speed of the river, and so I know how fast the river is going now. The river is flowing at 9 kilometers per hour, so I can label it appropriately. That one's a little bit different because you have to think about the downhill and the uphill and how that river's speed is going to affect your speed, right? So be careful with that type of problem. All right, I'm going to give you another triad problem. This is kind of like the river problem, upstream and downstream, but there's one little difference. So I need you to be careful on this one. Make sure you read it carefully before you actually set up your math equation. Why don't you try pausing the video, read this problem, see if you can set up your equation, and then solve it, and then make sure you get the correct answer. And you might need to do it in steps. You might need to try it first and then unpause the video and see if you've got it right before you keep going, but making sure that you can follow the process correctly. All right, it says a Hudson River tugboat goes 10 miles per hour in still water. So that's its speed by itself, nothing affecting it. It travels 24 miles upstream, so that's a distance, and 24 miles back in a total time of 5 hours. So that's a time. What is the speed of the current? You can call it C, you can call it X, you can call it R for river, whatever you'd like to call it. Just make sure you understand your variables and what your answer means in the end. All right, you need to be careful. Last time, in the last few examples, our times were equal, right? But on this one, our times aren't equal. What do we know about the time in this one? This one's a little bit different because now it gives us a total time. That's the time that you went upstream plus the time that you went back downstream equals a total time of 5 hours. So we're not going to set the times equal on this one. We're actually going to add the times together for a total time. A little bit different, right? So you got to be careful on these. All right, so we have the time upstream plus the time downstream for a total time. Let's try to plug in all of our information. Do we know the time it took us to go upstream? Ooh, no, we don't. Do we know the time that it took us to go downstream? Oh, shoot, I don't think we do. Do we know a total time? Oh, that we do know. We do know that's 5 hours, right? So I've got 1 out of the 3. All right, if we don't know anything about the times, don't we know that time is the same thing as what? Distance over rate? So maybe we know some information about the distance and the rate that we went upstream, and the distance and the rate that we went downstream. And can you plug in your information? All right, this is what I got. I knew that the distance upstream was 24 miles. I know that the speed upstream was going to be a little bit slower. My normal speed of 10 miles per hour was going to be slowed down by whatever the river was because I'm going to have to go up the stream, right, against the current. So that's how I got the 10 minus R, not R minus 10. Plus, I have to do the time going downstream. That's distance over rate. The distance was the same distance, right? 24 miles over my speed, which is my normal speed. But if I'm going downstream, aren't I going to be pushed a little bit faster because of the current? So whatever my normal speed is, 10 plus whatever the river's current is, so 10 plus R, equals that total time of 5 hours. So now I have a rational equation that looks like this. Unfortunately, this isn't a proportion anymore. Now I have 3 different fractions, but we've solved these before in a previous section. Let's get a common denominator. So it looks like this one has a 10 minus R, but it's missing that 10 plus R. It looks like the second fraction has a 10 plus R, but it's missing the 10 minus R. And the last one's missing both the 10 plus R and the 10 minus R. And now that my denominators are the same, once my denominators are the same, I can just worry about my numerators. And so now I have an equation that looks like this. I'm going to distribute, I'm going to FOIL, I'm going to distribute the 5. Pause the video. If you haven't done that yet, come back to me in a second and make sure you have all the same terms I do. I distributed both of my 24s. I FOILed my 2 binomials here, and now I still have to distribute the 5 through. After doing that and combining my like terms, I ended up with 480 is equal to 500 minus 5r squared. Hopefully you did too. I can go ahead and subtract 500 from both sides. I can divide, actually, I have an r squared, don't I? So I want to move everything to the same side if I can help it. So if I move that 5r squared to the left side to make it positive, I can add it over, and so then I have everything over to the same side because now I have a quadratic. So I end up with a 5r squared minus 20 equals 0. And look, in each term, can I GCF out a 5? If I factor out a 5, that leaves me with an r minus 4. And can't that be broken down even farther, factored even farther using a difference of squares? R minus 2, r plus 2. I can set each factor now equal to 0, and I end up getting r equals 2 and r equals negative 2. Now let's stop and think about what this means, r. Well, didn't r represent the speed of the river? So when I go and I get two answers, and one of my answers is r equals -2, then you're telling me that the river is moving at -2 miles per hour, which doesn't really make any sense, right? So that's a solution that we get. It just doesn't make sense in the context of our problem. So we're not going to use that as our answer. But +2 makes sense. Doesn't it make sense that the river can flow at 2 miles per hour? Maybe that's the current of the river. And so r equals 2 looks like it's our answer. It makes sense in our problem, and we're going to label it as the river is flowing at 2 miles per hour. That problem was a little bit different because we had a total time this time instead of the times being equal. You still had to be careful with your current of your river slowing you down or speeding you up. And then we had to get our common denominators and solve our rational equations. Whew, that was a really good one. You might want to practice that one more time before doing your homework on this section. I know this section's kind of challenging, but please make sure that you stick with it, that you do as much practice as you need to make sure that you get a hang of it, because we will have problems like this on our exam, okay?